Okay, good morning class. Reiterate ko lang na Saturday na exam, 4 to 6:30. Pero 2 hours lang yung exam. I mean, pwede nyo siyang kunin anywhere from 4 to 6:30. Okay? So, wala, pwede nag-start ka ng 4:30. That's okay. Kasi hanggang 6:30 naman. Alright. So, good luck. Today, tuloy tayo sa exam number 2 topics. Okay, so exam number 2 would be magnetic, we would be dealing with magnetic fields and such. Okay, sobrang parallel nito with the electric field. Meron din tayo mga flux, meron din tayo mga energy, and so on and so forth. Okay, so first things first, as usual, ang gagawin lang natin today is introduce ko kayo sa concept ng magnetic field. How do you imagine it? And how things work. Okay. Next meeting tayo magsasolve ng mga magnetic field talaga. Okay. Ayan. We have an image here. Okay. So last time, yung electric field, na-imagine natin siya as like glowing balls. Ayan. Glowing particles. Ibig sabihin nun, kung saan bright, kung saan yung bright parts, doon yung malakas yung electric field. Okay. So here, makikita natin, ito yung mga charges mo. So, bright sila dun sa gitna nila. Ibig sabihin, sa sa mga pwestong malapit sa kanila, doon malakas yung electric field. Okay? In a similar way, ganun sa magnetic field. Ganun sa magnetic field. Okay? Ang problema, ang iba nga lang is that yung magnetic fields, they come in lines. Okay? So, yung mga lines na yan, mga curves na yan, they produce sa magnetic field. And when you get near them, lumalakas din yung magnetic field. Okay, so paano natin malalaman no which one is which para in real life, 'di ba? Napansin mo parehas naman na pag lumapit ka lumalakas. Lumapit ka sa church, lumalakas ka. Lumapit ka dito sa mga lines na to, lumalakas. Yun din yung nararamdaman mong field. Okay. Napansin natin when we ito kuwari ito ay positive charges. This one is positive. This one is positive. And then pag pinaglapit mo sila, nalalaman mo that they would repel each other. Okay? So ilapit natin yung charge dito sa mga lines na ito. Suppose nandito yung charge mo. Suppose nandyan yung charge mo. Ang mangyayari, walang mangyayari. Okay? Walang nangyayari. Weird, diba? Parang, so paano yun? Okay? Tapos try pa natin mag-experiment pa. Okay. So, yung una natin ginawa, nilagay lang natin siya sa tabi niya. Okay, walang nangyari. However, if I move this charge going there, parallel to the line, okay, ang nangyayari is that this charge is sent away. Okay. It will be sent away from that magnetic field source. Okay? And then investigate mo ngayon kung ano ba tong line na to. So these lines are currents. So these are currents. And when you examine them, yung mga currents mo, they produce magnetic fields. Tapos ayun nga, pag tinabihan mo siya ng charge, wala nangyayari. Pero pag pinagalaw mo yung charge, say this current here has a direction there, like this. Ang mangyayari, ito, anti-parallel yung ginawa mong motion. Mapapalayo niya yung charge. Okay? Okay. And then what else? What else? So, syempre, familiar tayo sa mga magnets and such. Compass, ganyan. Okay. So, kapag nilapit mo yung compass mo dito, yan, lapit natin yung, lapit tayo ng compass. Hindi pala kita yung blue. Green na lang. Lapit tayo ng compass dito. Mapansin natin that kaganyan yung alignment ng compass mo. Okay? So, and when you put it on top, when you put it on top, here, nangyari naman is that it would point that way, yung compass mo. When you put it on the left, here, mapansin mo that the compass would go down. Okay? Nilagay mo sa ilalim, magpo-point naman to the right. Okay. So, ayun. Pansin mo na yung magnets mo, yung mga compass mo, when you place it near currents, umiikot yung direction niya. Okay? Umiikot yung direction niya. So, from that, i-ano na natin ngayon. Ano yung force na ginagawa ng isang magnetic field towards some charge? Okay? So, the magnetic force is given by this. Okay. Makikita natin in this example kung paano ba ito nagwo-work itong magnetic force mo. Okay, so yung magnetic force on the particle, on the charge, is given by V cross B. Okay, so yung motion ng yung V is velocity. So yung charge mo, kailangan may velocity siya to be affected by a magnetic force. Okay, so V cross B, ibig sabihin, Q, V, B, sine theta. Okay? Pag cross product, kailangan perpendicular sila para full force. Pag hindi, pag parallel sila, walang mangyayari. Okay? So, kapag sine theta, so that theta is the angle between those vectors, ang mangyayari, kapag V parallel with B, this would result into a zero force. V perpendicular with B. This would result to a force that is Q, V, B. Okay? Okay. So, kapag naka-angle, ganito yung itsura niya. Pag perpendicular, ganito yung itsura niya. And then kapag parallel, ganito. Alright. So, syempre, may right-hand rule tayo whenever we have cross products. Ayan. So, yung palms mo, ayan, ipapattern mo lang papunta kay V. And then, fingers mo would curl around papunta dun sa direction ni B. Okay? So, kung may V ka na direction pa ganito, tapos B papunta dun, therefore, the right-hand rule tells you yung thumb motion mo would be upward. Okay? So, yung kung papunta naman doon yung Q mo, tapos papunta dito yung V, yung B, sorry. Right-hand rule mo siya, so babaliktarin mo yung kamay mo. Babaliktarin mo yung kamay mo dito. Okay, kaya nakabaliktad yung drawing. And it tells you that the force points downward. Okay. Okay. So from here, let's characterize kung ano itsura ng makikita natin kung ano. Ibibigay ko lang muna kung ngayon kung ano itsura ng magnetic field ng isang current. Okay. So yung magnetic field ng isang current, tulad nga sabi ko, it circulates. Ito, sa example natin kanina sa mga compass na nilagay mo sa paligid, nakita mo na yung magnetic field goes around. Okay. And so on. So maraming lines going counterclockwise. Okay? So yung nararamdaman na force ni charge here for our example is upward. Okay, upward siya. Upward. Tapos yung velocity mo pa ganun. Therefore, V cross B, pa ganito yung force na mararamdaman mo. Okay. Okay. So that's one example. Let's try this another example. Meron tayong beam of protons moves at 3 times 10 to the 5th meters per second through a uniform 2 Tesla magnetic field. So yung units ng magnetic field is Tesla. Pwede rin Gauss. Tesla or Gauss would work. Yung Tesla ay, yung Gauss pala, is just a scaled Tesla. So Tesla is, Gauss is 10 to the negative 4 Tesla. Okay, so kasi yung natural units ng natural SI units ng ng magnetic field, it's so large. Yung Tesla, 1 Tesla is so big. Okay? So yung magnetic field ng Earth is 1 Gauss. Okay, so maliit lang yung in terms of Tesla ng ng magnetic fields natin ng Earth. Okay, so yung Tesla usually ginagamit siya sa laboratory setting kung saan nakakapag-produce ka ng malalaking magnetic fields. Okay, the velocity of each proton lies in the xz plane and is directed 30 degrees to the z-axis. Okay, so drawing tayo ng coordinate system. X, Y. Okay, by the right hand rule, Z ito. Okay. So meron akong direction ng 30 degrees. Ay, hindi. Baliktad. Siya. Okay, 30 degrees. Then you have your field going from here, from there to there, from there to here. Okay, so simply, your force is just F U V cross B or Q V B sine theta. You plug in your theta, this is also 30. So sine 30. Tapos V is given. Charge is given. So you can solve this. Okay, yun lang. Okay. So, eto. Yung magnetic field lines natin, very familiar tayo dyan dahil from the very beginning of our education system, makikita mo na tong figure na to. Okay? Yung mga magnet bars, ganito itsura ng nila, magnetic field lines nila. And we know this kasi, di ba, ang ginagawa natin usually sa experiment dito is that lalagay ka ng ganyan, ng magnet, and then bubuhusan mo siya ng ng iron filings. Tapos makikita mo they would line up to this kind of loops. Okay? So yung magnetic field lines natin, unlike electric field lines, yung magnetic field lines mo, they come in loops. Okay? And it's usually given by the right-hand rule. Hindi siya usually, is always given by the right-hand rule. Okay? Right-hand rule siya. Mapansin nyo, yung thumb nyo dapat direction ng I, ng current. Tapos, yung magnetic field with the curl from your hands. Okay? Try nyo dito yung right-hand rule, mapapansin nyo na ganun siya. Okay. So, kapag ganito yung mga magnetic field natin, kailangan natin ng bagong representation para sa mga 3D na bagay, no? Okay? So, kunyari, kasi 2D lang tayo, di ba? Paano mo i-drawing to sa papel? Okay? So, meron tayong dot or something like this. Okay? To indicate that the field is coming out of the plane. Okay? Coming out of the paper. In that case. And then, for this case, X naman, or something like this, it means that it's into the paper. Okay? Or into the screen. Okay. So, sabi ko nga, right-hand rule lang yung magnetic field ng isang current. And tapos, yung current mo, pwede mo i-bend. And you can see that, itong example, you can still use your right-hand rule to imagine the field. Ayan, tingnan nyo dito. Or dito pala mas madali. Okay. Yung current is coming out of the page. Therefore, by right-hand rule, you'd see that this is counterclockwise. Okay? Easily. Ayan. Kapag niloop mo yung currents mo, yung wires mo, makabuo ka ng ganito. So, ang tawag dito, solenoid. Okay, solenoid ang tawag sa kanya. And kamukha niya yung magnetic field ng bar magnet. Okay. So, sir, wala namang current sa mga magnets. Meron currents dyan. Okay, guys. Sa mga maliliit na molecules niya. May mga umiikot na electrons, di ba? So, pero on the next topic pa yan. Pero yun lang, just to give you a sanity check na bakit wala namang current dito pero meron kang magnetic field dahil yun sa mga current na pinoproduce ng mga revolving electrons dito. So, yung mga molecules sa magnets natin, they are usually aligned. Okay? Usually aligned. Yung mga they are aligned in such a way that yung mga electrons mo they actually revolve around your magnet. Okay, so that's why meron tayo may mga naturally occurring magnets tayo. Okay? Again, everything is in 3D. Okay? Mas emphasized ngayon yung pagiging 3D ng mga bagay-bagay. Unlike sa electric field lines na pwede mong imaginein lahat sa 2D. Alright. Ano pa ba? Okay, so ang daming right-hand rule din, as usual. Sa force, may right-hand rule ka. To imagine the magnetic field, may right-hand rule ka. Okay. Now let's try Gauss's law for magnetism. Similar way lang, B.dA, and then pansinin natin, let's do Gauss's law here. Okay. Kapag gumawa ka ng circle or spherical something, you try to just feel the magnet. You'd see that yung mga magnetic field lines coming from this side goes back into this side, sa likod, and so on and so forth. So lahat ng field lines pumapasok, lumalabas. And from that, okay, so lahat ng flux niya, meron kang positive term, tapos meron kang negative, meron kang flux incoming plus flux outgoing. Okay? And you could notice that all that is incoming is also the outgoing. So they would sulat natin properly. It's just okay. Ay din pala. Okay. Mapansin mo lahat ng incoming is just outgoing. And therefore, yung flux through a closed surface is always zero for magnetism. Okay, unlike electric fields. Okay, so useless ba ang flux sa magnetism? Hindi useless ang flux sa magnetism kasi pwede ka namang gumamit ng surface na hindi closed. Okay, so wag mo lang siya i-close. Magiging useful siya. Okay, so kunyari gusto ko lang kunin yung flux dito into this circle, then I could do that. That's very nice thing to know. Okay, for this part. And similarly, ganoon din dito. Pwede akong maggawa ng circle lang dyan to know how strong the magnetic field is. Okay? Pero next time na natin yung gagawin. Okay? Sinama ko lang siya dito dahil it's nice to know. Okay, that's it for the lesson today, pero hindi pa tayo tapos dahil sasagutan natin lahat ng prob set para naman para may onting review kayo sa exam niyo. Okay, again guys, 3D lahat sa magnetic field. Magnetic field circulates around your currents. Magnetic field circulates around your currents. And the magnetic fields affect moving charges. Okay? Magnetic fields affect moving charges. So, pag stationary lang si charge, walang mangyayari sa kanya under a magnetic field. Okay. Sige. I guess that's it for our lesson today. Tuloy natin yung hardcore next week. Kasi ayokong bigyan kayo ng hardcore. Baka hindi siya mag-stuck for now kasi may exam kayo. So next next Monday na. Okay? For now, imagine lang tayo kung paano ba yung magnetic field na yun. Alright.